When people think about modern war, they often think about headlines, maps, or political decisions.
But behind every movement on the battlefield is something far more concrete: cost.
Today, we're not looking at tactics or combat footage. We're looking at numbers.
From armored vehicles worth hundreds of thousands of dollars
to missile systems costing millions per unit. This is the real financial scale behind the vehicles supplied by the United States and Europe during the Russia-Ukraine conflict. Not opinions. Not speculation. Just documented systems, estimated costs, and what those numbers actually mean.
When most people think about modern warfare, they tend to focus on firepower.
Bigger guns. Heavier armor. More advanced technology.
But in reality, modern conflicts are shaped less by what a weapon can do, and more by how many can be built, maintained, replaced, and sustained over time. This is where cost quietly becomes one of the most powerful forces on the battlefield.
Not cost as a headline number. Not cost as a political argument.
But cost as a practical constraint, one that shapes decisions long before any vehicle ever reaches the field. Because in modern war, economics doesn't sit behind strategy.
It creates it. Budgets are the first battlefield.
Every military decision begins long before deployment, inside budgets and planning documents.
Governments do not decide to send vehicles in isolation. They decide how much money can be allocated across production, refurbishment, training, transportation, fuel, spare parts, long-term support. A vehicle that costs more to operate than to build may look impressive on paper,
but becomes a liability over time. This is why modern conflicts are often defined by what can be sustained, not what can be showcased.
A single advanced system may outperform older platforms in a controlled test environment. But wars are not controlled environments.
They are prolonged, unpredictable, and resource-intensive.
And in those conditions, cost shapes reality.
Production capacity matters more than perfection.
One of the most overlooked aspects of modern warfare is production speed.
A vehicle that takes years to build, requires specialized factories, and relies on rare components may be extremely capable.
But it cannot be scaled quickly. In contrast, older or simpler systems often have established production lines, existing spare part inventories, trained personnel already familiar with the platform. This means they can be repaired faster, replaced faster, and deployed in larger numbers. From a strategic perspective, a vehicle's replaceability can matter more than its peak performance. Because in a long conflict, losses are not hypothetical, they are expected. And systems that cannot be replaced at the same pace they are consumed create strategic pressure. Cost determines quantity, and quantity shapes strategy. Cost directly influences how many vehicles can be sent. This sounds obvious, but the implications are profound.
If one vehicle costs 10 times more than another, decision makers must ask:
is this system worth 10 alternatives? Does its performance justify reduced numbers? Can it be supported logistically at scale?
These questions don't diminish the value of advanced systems.
They contextualize them. In practice, militaries often adopt mixed approaches. A limited number of high-end platforms, supported by larger numbers of lower-cost vehicles. This balance allows flexibility while managing risk. Because losing one expensive system is not just a tactical loss. It can represent years of production, training, and financial investment.
Support costs never stop. The purchase price of a vehicle is only the beginning. Over time, support costs often exceed the original unit cost.
These include fuel consumption, routine maintenance, replacement parts, Software updates. Specialized tools. Trained technicians.
Some vehicles require highly specialized maintenance crews and controlled environments.
Others are designed to operate with minimal infrastructure. This distinction becomes critical in extended conflicts.
A vehicle that performs exceptionally but requires constant support may be unsuitable for prolonged deployment under constrained conditions. Cost, in this sense, becomes a measure of operational resilience.
Logistics, the hidden cost driver.
Logistics rarely capture public attention, but they consume a significant portion of military spending.
Every vehicle requires transportation to the operational area, secure supply routes, fuel and consumables, recovery and repair capability.
The heavier and more complex a system is, the greater the logistical burden.
This doesn't mean heavy systems lack value. It means their deployment must be deliberate and limited.
From a strategic standpoint, cost forces planners to ask:
can this system be moved easily? Can it be repaired close to the field? Can spare parts be sourced quickly?
If the answer is no, then cost becomes a limiting factor regardless of performance.
Training is a cost multiplier. Another often overlooked factor is training.
Advanced vehicles require advanced crews.
That means
longer training cycles,
specialized simulators, higher personnel costs, ongoing retraining.
In contrast, simpler platforms can often be operated effectively with shorter training periods.
This matters because training is not a one-time expense. Crews rotate. Personnel change. Vehicles evolve. Every hour spent training represents both time and money.
And in large-scale conflicts, training capacity can become a bottleneck.
Expensive systems are powerful but not always replaceable. This is one of the central realities of modern warfare. High-end systems deliver impressive capabilities. Superior sensors, enhanced protection, advanced networking. But they often come with limitations. Long production timelines, complex supply chains, high per-unit replacement costs.
When such a system is lost or damaged, replacement may take months or even years.
That doesn't make it ineffective.
It makes it strategically precious.
As a result, these systems are often used selectively. Not because they lack capability, but because their cost demands caution. The value of good enough. In prolonged conflicts, a concept often emerges: good enough capability. This does not mean low quality. It means balanced design. Vehicles that perform reliably, are affordable to maintain, can be replaced quickly, fit existing logistical networks. These systems may not dominate in isolated comparisons, but they excel in sustained use. From an economic standpoint, good enough platforms often deliver the highest strategic return.
Because they remain present day after day, month after month.
Cost as a strategic signal.
Cost also carries symbolic weight.
Deploying expensive systems signals commitment. Deploying large quantities signals endurance. Both matter. But endurance often shapes outcomes more than symbolism.
A system that can be maintained, repaired, and replaced sends a different message. One of long-term capability rather than short-term impact. In this way, cost influences not just logistics, but perception.
Simple comparisons for scale, illustrative. To understand these numbers, it helps to think in familiar terms. The cost of a single modern military vehicle can be comparable to public infrastructure projects, civil transportation investments, large community developments. These comparisons are not political. They are illustrative. They help explain why decisions are made cautiously, and why cost is discussed alongside capability. Every vehicle represents more than metal and electronics. It represents allocation. Why this chapter matters. Understanding cost changes how we interpret everything that follows. It explains why some vehicles appear in large numbers, why others appear in limited roles, why older systems continue to be used, why replacement timelines matter. Without understanding economics, it's easy to misinterpret decisions as purely tactical. In reality, they are often financial, industrial, and logistical. Transition to next chapter. With this foundation in place, we can now look at specific vehicle categories. Not to judge their effectiveness, but to understand why certain systems were chosen, supported, and deployed. Because once cost enters the picture, modern warfare looks very different. Armored personnel carriers rarely dominate headlines. They don't feature cutting-edge sensors. They don't carry the heaviest weapons. And they are rarely presented as symbols of technological superiority. Yet in modern conflicts, these vehicles form the backbone of mobility. Their purpose is not to overwhelm. It is to move people safely, consistently, and repeatedly, often under difficult conditions, while remaining affordable enough to deploy in large numbers. In long-duration conflicts, this role becomes indispensable. The function over the spotlight. Armored personnel carriers, or APCs, are designed around a simple concept: transport personnel while providing basic protection and reliability. They are not intended to engage in direct combat. They are not optimized for aggressive maneuver. Instead, they emphasize enclosed protection, mechanical simplicity, adaptability, ease of maintenance. Because of this, APCs often represent the most cost-effective category of armored vehicles in service. They are present in large numbers not because they are flashy, but because they work. Why volume matters. In sustained operations, numbers matter. Not in the sense of massing force, but in maintaining continuous capability. APCs are required for transporting personnel, evacuation and recovery, support and logistics tasks, training and reserve operations. Because these missions occur constantly, APCs must be available, reliable, reparable. This is where cost becomes decisive. A vehicle that can be deployed widely without exhausting resources gains strategic value simply by being present. M113, the benchmark for longevity, USA. The M113 is one of the most widely produced armored vehicles in history. Originally introduced decades ago, it has remained in service in one form or another across numerous countries and environments. Its continued relevance is not a result of superior protection or firepower. It is a result of design philosophy. The M113 emphasizes lightweight construction, straightforward mechanics, high adaptability, low operating complexity. Because of this, it can be refurbished, upgraded, and repurposed rather than replaced entirely. Cost perspective, safe, approximate. When refurbished and modernized, M113 variants typically represent a fraction of the cost of newer armored platforms, lower fuel consumption, reduced maintenance requirements. This makes the vehicle particularly attractive in situations where quantity and endurance matter more than peak performance. Maintenance as a strategic advantage. One of the M113's defining strengths is maintainability. Spare parts are widely available. Maintenance procedures are well documented. Training pipelines already exist. This means Repairs can be conducted quickly. Vehicles spend more time operational.
Support costs remain predictable. In long conflicts, predictability matters.
A system that consistently performs within known limits is often preferred over one that offers superior capability but uncertain sustainability. Marder, protection with familiarity, Germany.
The Marder occupies a different position. While more robust than early APC designs, it retains many of the same principles.
Proven design.
Established logistics.
Long service history.
Originally designed during a different era, the Marder has undergone numerous upgrades rather than wholesale replacement. This incremental evolution has allowed it to remain relevant without incurring the full cost of a new platform.
Cost considerations.
Refurbished Marder vehicles typically involve
significant investment in overhauls rather than new production. Reuse of existing components.
Compatibility with known support systems. While more expensive to operate than lighter APCs, the Marder offers increased protection while remaining within manageable cost boundaries.
FV432 Simplicity and Endurance, United Kingdom. The FV432 represents another approach to APC design. It prioritizes simplicity, reliability, low mechanical complexity.
The vehicle's design reflects a philosophy where ease of use and maintainability outweigh advanced features. This has made it particularly suitable for support roles,
training functions, secondary transport duties. Cost profile.
Because of its straightforward construction, the FV432 typically involves
lower refurbishment costs, minimal electronic dependencies, reduced maintenance specialization. This allows the platform to remain in service without requiring extensive modernization programs.
YPR 765 adaptation through modification, Netherlands. The YPR 765 is based on a well-understood platform design and has been adapted for multiple roles over time.
Rather than developing a completely new system, the emphasis has been on modularity, role-specific adaptations, incremental improvements. This approach keeps costs contained while extending operational life. Economic efficiency.
Vehicles like the YPR 765 demonstrate how
modest upgrades can deliver meaningful improvements.
Existing production knowledge reduces risk.
Support infrastructure remains usable. The result is a platform that may not lead in any single category, but performs reliably across many. Why older vehicles remain relevant.
At first glance, it may seem counterintuitive to rely on vehicles designed decades ago.
But age alone does not determine usefulness.
Older APCs often offer advantages such as
proven reliability, known limitations, established logistics, lower replacement costs. In long-term scenarios, these characteristics become decisive. A vehicle that can be repaired repeatedly, even if it lacks advanced features, can outlast more complex systems.
Cost beyond the purchase price. As discussed in the previous chapter, the true cost of a vehicle extends far beyond acquisition. For APCs, operating costs are particularly important.
These include fuel consumption, routine servicing, wear and tear repairs, personnel training. Older APCs tend to score well in this category.
Their systems are often mechanical rather than digital.
Their components are accessible.
Their failure modes are understood.
This reduces downtime and keeps fleets operational. Logistics compatibility. Another major advantage of legacy APCs is compatibility. They are often transportable using existing infrastructure. compatible with standard tools,
supported by established supply chains. This compatibility reduces the need for new investments.
In contrast, introducing a new platform may require specialized transport, new training programs,
new storage and repair facilities.
These hidden costs can exceed the price of the vehicle itself.
Strategic flexibility through numbers. When APCs are affordable and available in volume, they provide flexibility.
They can be reassigned, repurposed,
rotated through maintenance cycles. This flexibility allows planners to adapt without overcommitting resources. It also reduces risk. If one vehicle is unavailable, another can take its place without significant disruption.
Why APCs appear in large numbers? The presence of large numbers of APCs is not accidental. It reflects a strategic calculation. Transport capacity must be consistent. Losses must be replaceable. Support must be sustainable. APCs satisfy these requirements better than almost any other armored category. They do not need to be exceptional. They need to be dependable. Endurance over elegance. In prolonged conflicts, endurance often matters more than elegance. APCs embody this principle.
They may lack advanced features, but they offer
continuous availability, predictable costs, operational consistency.
These traits are difficult to quantify, but they shape outcomes over time.
Transition to the next chapter. With an understanding of why APCs remain so widely used, we can now turn to a category that builds upon them. Vehicles designed not just to transport,
but to operate alongside troops with increased protection and capability. In the next chapter, we examine infantry fighting vehicles and how cost begins to rise as roles expand. Infantry fighting vehicles sit at the crossroads of modern armored design. They are not as simple as armored personnel carriers. They are not as heavy or specialized as main battle tanks.
Instead, IFVs are designed to do more.
And that more is where cost begins to rise. To understand why infantry fighting vehicles are significantly more expensive than APCs, we have to look beyond surface features and into the design trade-offs that define them.
Because IFVs are not just transport platforms. They are integrated systems. The expanded role of IFVs. Unlike APCs, IFVs are intended to operate closer to active areas while carrying personnel. This expanded role requires increased protection, greater situational awareness, enhanced mobility under load, integrated electronics.
Each of these elements adds cost not just in manufacturing, but throughout the vehicle's lifecycle.
Where APCs focus on movement and endurance, IFVs focus on presence and protection.
That distinction shapes everything.
Why IFVs cost more than APCs? The cost difference between APCs and IFVs is not incremental, it is structural. IFVs incorporate heavier armor packages, reinforced hulls and suspensions, advanced optics and sensors, digital communication systems. These additions increase vehicle weight, maintenance complexity, training requirements. Every added capability multiplies cost across production, support, and replacement. An IFV is not just a stronger APC. It is a different category entirely.
Armor versus weight, the first trade-off.
One of the most fundamental trade-offs in IFV design is armor versus weight. More armor provides better protection, but more weight reduces speed, range, transportability. It also increases fuel consumption, mechanical stress, Maintenance frequency.
Designers must balance survivability against mobility and cost. This is why IFVs vary significantly in size and weight even within the same generation.
There is no universal solution. Every design reflects a philosophy. Electronics versus simplicity. Another major cost driver in IFVs is electronics. Modern IFVs integrate targeting systems, observation equipment, digital communications, onboard diagnostics.
These systems enhance awareness and coordination.
But they also increase acquisition cost, maintenance complexity, dependency on specialized support. In contrast, simpler systems offer greater reliability under stress, faster repairs, lower long-term costs. The choice between advanced electronics and mechanical simplicity is not about right or wrong. It is about what can be sustained. Survivability philosophy. Survivability in IFVs is not defined by armor alone. It includes detection and awareness, vehicle layout, redundancy, mobility. Different IFVs prioritize different aspects. Some emphasize heavier protection. Others emphasize agility and awareness.
Each approach carries cost implications. Heavier protection increases unit cost and reduces replaceability.
Lighter protection increases reliance on awareness and movement. These philosophies shape not just vehicle design, but deployment strategy. Bradley IFV Capability Through Integration, USA. The Bradley IFV represents a design philosophy centered on integration. It combines substantial protection, advanced optics, digital systems, networked communication.
This integration allows the vehicle to operate effectively within complex environments.
But integration comes at a price. Cost perspective. The Bradley's cost reflects sophisticated onboard systems, higher maintenance requirements, specialized training. Refurbished variants remain significantly more expensive than legacy APCs.
However, the cost is justified by the vehicle's ability to operate in demanding roles. This makes the Bradley a high-capability, high-investment platform. Life cycle cost matters.
For vehicles like the Bradley, acquisition cost is only part of the picture. Long-term costs include software updates, component replacement, system calibration, specialist maintenance. These costs accumulate over time. As a result, Bradleys are often deployed deliberately rather than in overwhelming numbers. They represent concentrated capability rather than mass deployment. CV90 Modular Balance, Sweden. The CV90 reflects a different approach. Designed with modularity in mind, it emphasizes adaptability, balanced protection, scalable electronics. Rather than pushing one aspect to the extreme, the CV90 seeks a middle ground. This design allows variants with different protection levels, adjusted electronic suites, role-specific configurations, cost implications. Modularity introduces upfront cost, but it reduces long-term expense by allowing upgrades rather than replacement. The CV90 demonstrates how thoughtful design can balance affordability with capability. It is not the cheapest IFV, but it is designed to control costs over time. Marder 1A3 Proven Design, Updated Protection, Germany.
The Marder 1A3 occupies a unique position.
Originally designed in an earlier era, it has been updated to meet modern requirements. Rather than reinventing the platform, upgrades focused on Improved protection. Incremental system improvements. Structural reinforcement. This approach keeps costs lower than entirely new designs while extending operational life. Economic rationale. Refurbished Marder variants benefit from existing logistics networks, known maintenance procedures, familiar training pipelines. While not as electronically advanced as newer IFVs, the Marder offers reliable protection at a controlled cost. Cost per vehicle versus survivability. One of the most important strategic considerations is cost per survivable unit. This is not just about how well a vehicle performs, but how often it can be replaced. A highly survivable vehicle that is prohibitively expensive may reduce overall fleet resilience. Conversely, a moderately protected vehicle that can be fielded in greater numbers may provide greater overall endurance. This trade-off influences procurement decisions across NATO and European forces. Animated cost comparisons, retention queue. To visualize this, consider cost bars rather than combat scenes. APC baseline cost. IFV mid-range cost. Tank high-end cost. This comparison highlights how IFVs occupy the middle ground. They represent a significant investment, but one that delivers proportional capability. Maintenance and downtime. As IFV complexity increases, so does downtime. Advanced systems require diagnostic equipment, specialist technicians, controlled maintenance environments. This increases the time vehicles spend offline. Designs that prioritize accessibility and modular repairs can mitigate this, but not eliminate it. Cost is measured not only in money, but in availability, training, and human cost. Advanced IFVs also require more extensive training. Operators must understand vehicle systems, electronic interfaces, maintenance procedures. This increases training duration, personnel investment, replacement time. In long conflicts, training capacity becomes a limiting factor. This further reinforces the importance of balancing complexity with practicality. Why IFVs are deployed selectively. IFVs are rarely used indiscriminately. Their cost and capability make them suited for key operational roles, areas where protection matters most, situations requiring coordination. They are not expendable, but they are effective when used deliberately. The middle ground of modern warfare. Infantry fighting vehicles represent the middle ground between mobility and protection. They are more capable than APCs, less specialized than tanks, more expensive than transport vehicles, more flexible than heavy armor. This balance makes them essential, but also carefully managed. Transition to the next chapter. As vehicle protection and capability increase, so does cost. In the next chapter, we move beyond IFVs and examine the most expensive ground platforms supplied by Western nations. Main battle tanks, where power, protection, and cost reach their peak. Few military vehicles carry as much symbolic weight as the main battle tank. Tanks are often seen as the ultimate expression of land power. Large, armored, and unmistakably imposing. They dominate imagery, documentaries, and popular imagination. But behind that symbolism lies a more complex reality. Main battle tanks are not just powerful. They are expensive to acquire, expensive to operate, and expensive to sustain. And in modern conflicts, those costs shape how and how often they are used. Tanks as strategic assets, not just weapons. In earlier eras, tanks were produced in enormous numbers. Quantity itself was a form of strength.
Modern main battle tanks, however, are fundamentally different.
They are highly complex systems, built in limited numbers,
supported by specialized infrastructure.
This shift means tanks are no longer treated as expendable assets. They are strategic investments. Each vehicle represents years of industrial effort, training, and financial commitment. Why tanks cost so much? The cost of a modern tank is driven by several layers of complexity. At the most basic level, tanks require heavy armor, powerful engines, advanced suspension systems.
But beyond that, modern tanks also incorporate sophisticated fire control systems,
integrated sensors and optics, digital communication networks, specialized defensive features.
Each of these elements adds cost not only during production, but throughout the tank's entire service life.
A tank is not a single purchase.
It is a long-term obligation.
Refurbishment versus new production.
One of the most important cost decisions surrounding tanks is whether to build new vehicles or refurbish existing ones.
New production offers updated designs, modern manufacturing standards, longer projected service life.
But it also comes with
extremely high upfront costs, long production timelines, limited annual output. Refurbishment, by contrast, focuses on upgrading existing hulls, replacing outdated components, extending operational life. For many countries, refurbishment represents a practical compromise. It allows tanks to remain relevant without the cost of starting from scratch.
The economics of refurbishment. Refurbished tanks often cost significantly less than newly produced ones.
However, refurbishment is not inexpensive. It still involves structural inspections, component replacement, systems integration, testing and certification.
The advantage lies in reuse. By retaining major structural elements, refurbishment avoids the most expensive stages of production.
This approach explains why many tanks in service today trace their origins back decades, even if their internal systems are far more modern.
M1A1 Abrams capability with high operating costs, USA.
The M1A1 Abrams is one of the most recognizable tanks in the world. Its design prioritizes high protection, powerful mobility, advanced systems integration.
These qualities make it highly capable.
But they also make it expensive to operate.
Cost characteristics.
The Abrams operating costs are influenced by a powerful engine optimized for performance, sophisticated onboard systems, high maintenance standards.
Fuel consumption, in particular, is a significant factor. Without getting technical, the Abrams requires substantial fuel support compared to lighter vehicles.
This does not make it inefficient. It reflects the performance envelope it was designed to operate within. Fuel as a strategic cost. Fuel is not just a consumable. It is a logistical commitment. Every tank requires continuous fuel supply, transportation and storage, protection of supply routes.
As vehicle weight and power increase, so does fuel demand.
This means that deploying tanks is not just about moving vehicles. It is about sustaining an entire support network. Fuel costs accumulate quietly but steadily.
Over time, they become one of the largest contributors to total operating cost.
Leopard 2 efficiency through design evolution, Germany. The Leopard 2 family represents a different design philosophy.
While still heavily armored and powerful, it emphasizes
mechanical efficiency, modular upgrades, Maintainability.
The Leopard 2A4 and 2A6 variants illustrate how incremental improvements can extend service life without complete redesign.
Cost implications. Leopard 2 tanks benefit from common components across variants, established European support networks, experience accumulated over decades.
This reduces some long-term costs, particularly in maintenance and logistics coordination.
However, the Leopard 2 remains a premium system. Its protection and performance come with substantial financial requirements. Challenger 2 Protection and Precision, UK. The Challenger 2 reflects a philosophy focused on heavy protection, crew survivability, precision systems.
Rather than emphasizing speed or lightweight design, it prioritizes durability. This approach shapes its cost profile.
Economic characteristics. Challenger 2 tanks involve extensive armor systems, specialized maintenance procedures, smaller production numbers. Lower production volume increases per unit cost. At the same time, the tank's design emphasizes longevity, aiming to reduce the need for frequent replacement. Training, the hidden investment. Tanks do not operate themselves. Each vehicle requires a trained crew.
And training is one of the most significant long-term costs.
Tank crews must learn vehicle operation, system management, maintenance awareness.
Advanced tanks require longer training cycles than simpler vehicles.
This represents higher personnel costs, greater time investment, reduced flexibility in crew replacement. Training does not end once a crew is qualified.
It must be sustained throughout the vehicle's service life.
Logistics, heavy vehicles, heavy demands.
Supporting tanks requires specialized logistics.
This includes heavy transport vehicles, reinforced infrastructure, specialized recovery equipment. Tanks cannot be moved or repaired as easily as lighter vehicles.
Every deployment requires careful planning.
This planning translates into cost. Not just financial, but organizational. The heavier and more complex the tank, the greater the logistical footprint. Cost versus presence. Because of these factors, tanks are rarely deployed in large numbers. They are used where their capabilities matter most. This selective use reflects a strategic calculation. Maximum effect. Controlled risk. Managed expense. A tank's value lies not in constant presence,
but in decisive capability when required.
Tanks as signals of commitment.
Beyond their practical role, tanks carry symbolic weight.
Deploying main battle tank signals. Long-term commitment. Industrial support. Strategic seriousness. But symbolism alone does not justify cost. Every deployment decision must balance capability, sustainability, replacement potential.
In modern conflicts, endurance often matters more than spectacle.
Survivability and cost. High survivability reduces losses, but it increases unit cost. This creates a paradox.
The more resources invested in protecting a single vehicle, the fewer vehicles can be fielded overall. There is no perfect balance.
Each tank design represents a different answer to the same question. How much protection is enough and at what price?
Why tanks are used carefully. Main battle tanks are powerful, but they are not flexible in every context.
Their cost encourages deliberate deployment, careful maintenance,
conservative risk management.
This does not diminish their value. It highlights their importance. When tanks are deployed, it reflects a decision that the situation justifies the expense. Understanding the price of power.
When we look at tanks purely through the lens of performance, it's easy to miss the bigger picture.
Every tank represents years of design and testing, extensive training investment, continuous logistical support. They are not tools to be used casually. They are strategic assets, and their cost ensures they are treated as such. Transition to the next chapter.
As we move forward, we step away from armored vehicles designed to move and protect personnel. Next, we examine systems where cost accumulates not just in vehicles,
but in every single use.
Artillery and rocket systems, where the price of modern warfare is measured shot by shot. Why cost per shot matters.
When people think about modern warfare costs, they often picture vehicles, tanks, armored transports, aircraft. But over time, one category quietly absorbs more resources than almost any other: artillery. Not because artillery systems are the most expensive vehicles, but because they are used continuously. And in long conflicts, repetition drives cost more than complexity. Artillery, the constant presence.
Artillery systems do not seek attention.
They do not maneuver dramatically. They do not symbolize technological dominance in the way tanks or aircraft do. Instead, they operate steadily day after day, providing indirect support that shapes the operational environment. This steady use is exactly why artillery dominates budgets over time. A vehicle may be purchased once,
but artillery systems generate costs every time they are used.
Understanding cost per shot, high level.
When discussing artillery economics, one concept matters more than any other:
cost per shot. This does not refer only to ammunition. It includes wear on the system, maintenance requirements, barrel replacement over time, logistics and transport, personnel and training. Each use contributes incrementally to long-term expense.
And unlike many other systems, artillery is designed to be used repeatedly.
That makes its economic footprint unique. Unit cost versus lifecycle cost.
At first glance, artillery systems may appear less expensive than armored vehicles.
In terms of unit cost, this is often true.
However, unit cost tells only part of the story. Lifecycle cost, the total cost of owning and operating a system, is where artillery becomes significant.
A system that remains active over months or years accumulates expenses quietly but relentlessly. This is why planners focus not only on acquisition, but on sustainability. M777 Howitzer, Lightweight, Strategic Reach, USA. The M777 howitzer represents a modern approach to artillery design. It emphasizes reduced weight, mobility, compatibility with existing logistics. Its lightweight construction allows for flexible deployment options.
But reduced weight does not mean reduced cost.
Unit cost perspective. The M777's unit cost reflects advanced materials, precision manufacturing, modern design standards.
While more affordable than some self-propelled systems, it remains a significant investment.
And like all artillery, its long-term cost depends heavily on sustained use. Sustained use costs, non-technical. Over time, systems like the M777 incur costs related to structural stress, component replacement, calibration and inspection, transportation and setup. These are normal aspects of operation, but they accumulate.
A system designed for reliability still requires care.
The more consistently it is used,
the more resources must be dedicated to keeping it operational. Caesar Mobility with Integration, France. The Caesar artillery system represents a different philosophy. Rather than focusing purely on the gun itself, Caesar integrates artillery capability with a mobile platform. This approach offers faster relocation, reduced setup time, greater operational flexibility. However, integration introduces additional cost factors. Cost considerations. The Caesar system includes a vehicle platform, artillery components, integrated systems. This raises the unit cost compared to towed systems. At the same time, it can reduce certain operational costs by streamlining movement and support. This trade-off reflects a broader theme in artillery economics. Pay more upfront to manage long-term efficiency. PZH 2000 performance at a premium, Germany. The PZH 2000 is often cited as one of the most advanced self-propelled artillery systems. Its design prioritizes high protection, advanced automation, sustained performance. These qualities make it extremely capable and extremely expensive. Unit cost and complexity. The PZH 2000's cost reflects heavy armored chassis, sophisticated systems, complex manufacturing. This places it at the higher end of artillery investment. But cost alone does not determine value. Its design emphasizes endurance under demanding conditions, which can justify the expense when used selectively. Why self-propelled systems cost more? Self-propelled artillery systems combine multiple cost drivers. Vehicle maintenance, artillery maintenance, integrated electronics, fuel consumption. This makes them more expensive than towed systems both to purchase and to operate. However, they also offer advantages. Reduced reliance on external transport, faster repositioning, integrated protection. Once again, cost reflects trade-offs rather than superiority. Ammunition, the quiet budget driver. Although we avoid specific figures, it's important to understand that ammunition represents a recurring cost. Unlike vehicles, ammunition is consumed. Each use requires manufacturing, transport, storage, handling. Over time, these costs can exceed the price of the artillery system itself. This is one of the reasons artillery dominates budgets in prolonged conflicts. The system may remain the same, but the supporting resources continue to flow. Wear and maintenance over time. Artillery systems experience mechanical stress with each operation. This leads to increased inspection frequency, component replacement, barrel wear management. These processes are essential for safety and reliability. They also require skilled personnel and specialized facilities. Maintenance is not optional. It is the cost of sustained capability. Logistics at scale. Artillery logistics extend far beyond the gun. They involve transport vehicles, support equipment, maintenance infrastructure. Unlike lighter systems, artillery support must operate continuously. This creates a steady demand for fuel, spare parts, personnel. Over time, logistics become one of the largest contributors to total cost. Why artillery budgets grow over time? Artillery systems dominate budgets not because they are inefficient, but because they are essential and persistent. They are used regularly, repeatedly, over long periods.
This persistence turns small per-use costs into major expenditures.
In economic terms, artillery represents cumulative cost.
Even modest systems become expensive when used consistently.
Reliability versus cost control.
Artillery systems are designed for reliability.
But reliability does not eliminate cost.
It manages it. A reliable system reduces unexpected failures, allows planned maintenance, improves budgeting accuracy. This predictability is valuable. It allows planners to manage resources effectively, even when total costs are high. Why artillery is rarely replaced quickly. Unlike vehicles that may be phased out or upgraded, artillery systems often remain in service for decades. This longevity reflects proven designs, upgrade potential, cost effectiveness over time. Replacing an entire artillery fleet is expensive. Upgrading existing systems often offers better value. This reinforces the role of artillery as a long-term investment. Artillery as an economic anchor. Once deployed, artillery systems anchor resources around them. They require ongoing support, continuous logistics, dedicated personnel. This creates a stable but demanding cost structure. Artillery does not spike budgets suddenly. It pulls on them steadily. Comparing artillery to other systems.
When compared to tanks or IFVs, artillery often appears less dramatic.
But financially, it can rival or exceed them over time. Why? Because tanks may be used selectively. Artillery is used continuously. This difference defines their economic impact.
The strategic importance of cost awareness. Understanding artillery cost is essential for interpreting modern conflicts.
It explains
why certain systems are prioritized, why supply chains matter so much, why sustained support is emphasized.
Artillery is not just a weapon category. It is a budgetary reality. Transition to the next chapter. As we move forward, we shift from systems that deliver effects over distance to systems designed to prevent them. In the next chapter, we examine air defense vehicles,
where cost is shaped not by use, but by readiness and protection.
Defensive systems, high price tags.
Air defense systems occupy a unique place in modern warfare.
Unlike tanks or artillery, their value is not measured by movement or presence. It is measured by prevention. They are designed not to take ground, but to protect it.
And this defensive role comes with some of the highest costs in modern military budgets.
The paradox of air defense cost. One of the most striking realities of air defense is a simple paradox. Defensive systems often cost more than the threats they intercept. This is not inefficiency. It is the result of what air defense is required to do. Air defense systems must detect threats early, identify them accurately, respond reliably, operate continuously.
Failure is not measured in missed opportunities,
but in consequences avoided.
This demand for reliability drives cost upward. Air defense is a system, not a vehicle. Unlike many military platforms, air defense cannot be understood by looking at a single vehicle.
It is a system of systems. That system includes sensors and radar, command and control units, launch platforms, support and logistics vehicles. Each element contributes to cost, and removing any one of them reduces effectiveness dramatically. This interdependence is one of the primary reasons air defense systems are expensive. Why air defense requires constant readiness.
Air defense systems cannot be activated only when needed. They must remain
powered, maintained, staffed, integrated. This constant readiness generates cost even during periods of inactivity.
Unlike artillery or tanks, which can be stored or rotated, air defense systems must remain vigilant.
Readiness itself becomes a budget line.
NASAMS, distributed defense through integration.
The NASAMS system represents a modern approach to air defense.
Rather than relying on a single, centralized platform, it emphasizes distributed launch vehicles,
networked sensors, centralized command.
This architecture improves coverage and flexibility. But it also increases complexity. Cost structure. NASAMS launch vehicles are only one part of the system.
Total cost includes radar units, command vehicles, communication networks, maintenance support.
While individual components may appear modest, the complete system represents a significant investment.
This reflects the value placed on reliability and adaptability. Integration as a cost driver. Systems like NASAMS rely heavily on integration. Integration allows different components to communicate seamlessly. But integration requires software development, secure communication links, continuous updates.
These elements add to long-term cost.
Unlike mechanical systems, digital systems evolve continuously. Keeping them functional and secure requires ongoing investment. IRIS-T SLM Precision and Protection, Germany. The IRIS-T SLM platform represents another modern air defense philosophy. It emphasizes high accuracy, rapid response capability, advanced tracking. To achieve this, the system relies on sophisticated sensors and guidance technology. Economic characteristics. IRIS-T SLM systems involve specialized launch platforms, dedicated support vehicles, high-end electronics. These elements drive unit cost upward. However, the system's design focuses on minimizing risk to protected areas. In economic terms, it prioritizes risk reduction over cost minimization. Cost beyond interception.
When evaluating air defense, it's easy to focus on the cost of interception itself.
But interception is only the final step. Costs also include continuous monitoring, system calibration, training and certification, spare parts and redundancy.
Air defense systems are built with redundancy because failure is unacceptable.
Redundancy adds cost,
but reduces risk. Patriot Support Vehicles, Heavy Infrastructure, USA. The Patriot system illustrates the scale of modern air defense infrastructure. It is not a single vehicle or launcher. It is a network supported by radar vehicles,
command units, power generation, transport and maintenance vehicles.
Each support element contributes to overall cost. Support costs. Patriot support vehicles require
specialized maintenance, trained operators, significant logistical planning.
This makes the system resource intensive.
But it also delivers one of the most comprehensive air defense capabilities available.
Why support vehicles matter? Support vehicles rarely receive attention.
Yet they represent a large portion of air defense cost. Without them, systems cannot operate continuously. Readiness declines. Reliability suffers.
Support vehicles ensure
power supply, mobility, maintenance access. They are essential and expensive. Training, precision demands investment.
Air defense systems require highly trained personnel.
Operators must understand system interfaces, identification protocols, coordination procedures.
Training cycles are long and specialized. This increases personnel cost and limits rapid expansion.
Unlike simpler systems, air defense crews cannot be replaced quickly.
This further increases the strategic value of each system.
Layered defense, the big picture, retention queue. To understand air defense cost, it helps to zoom out. Modern air defense is layered. Different systems cover different ranges, different altitudes, different response times. This layering improves protection, but multiplies cost. Each layer requires its own vehicles, sensors, personnel. The result is a comprehensive shield and a substantial investment. Why air defense dominates budgets without visibility?
Unlike tanks or aircraft, air defense systems are often invisible.
They do not move dramatically. They do not dominate visuals.
Yet their cost impact is significant.
They require constant funding, continuous updates, ongoing training. Their absence is rarely noticed until it matters. Cost versus threat economics.
The idea that defensive systems cost more than the threats they counter is often misunderstood. Air defense is not about matching cost. It is about preventing damage. The cost of interception must be weighed against the cost of what is being protected. In this context, high cost becomes rational.
Sustainability and long-term planning.
Air defense systems are designed for long service lives.
This requires upgrade pathways, modular components, long-term funding commitments.
These factors increase initial cost, but improve sustainability. Replacing air defense systems frequently is impractical.
Upgrading them is more economical. Why air defense systems are deployed selectively?
Because of their cost, air defense systems are deployed deliberately.
They protect critical infrastructure, strategic locations, high-value assets. They are not spread uniformly. This selective deployment reflects cost awareness rather than limitation. Air defense as insurance. From an economic perspective, air defense functions like insurance. It requires continuous payment. It offers protection rather than return.
Its value is realized in what does not happen.
This makes it difficult to quantify, but essential. Understanding the price of protection.
Air defense systems represent one of the clearest examples of cost-shaping strategy. They are expensive because they must be reliable, continuous, and precise. They are maintained because the cost of failure is far greater. In modern conflicts, protection is not passive.
It is engineered and funded. Transition to the next chapter.
With air defense systems in place, we now turn to vehicles that rarely appear in footage, but make every other system possible.
In the next chapter, we examine logistics and support vehicles.
The hidden majority behind modern military cost.
The hidden majority.
When people think about the cost of modern warfare, they usually imagine armored vehicles,
tanks, infantry fighting vehicles, artillery systems.
But these platforms represent only a visible fraction of the total picture. Behind every armored unit is a much larger, quieter fleet. Logistics and support vehicles.
They rarely appear in headlines. They rarely feature in documentaries. Yet without them, nothing moves. the backbone of every operation. Logistics and support vehicles form the foundation of modern military operations. They are responsible for recovery and repair, construction and engineering, fuel and supply transport, equipment movement. These vehicles do not seek attention. Their purpose is continuity. They ensure that systems remain operational, supplied, and mobile over time. In economic terms, they represent infrastructure on wheels. Why support vehicles matter more than they appear? A tank without fuel is stationary. An IFV without maintenance is unavailable. An artillery system without transport cannot be sustained. Support vehicles enable every other platform to function. This means their impact is multiplied. A single recovery vehicle can keep multiple armored vehicles operational. A single fuel truck can extend the range and endurance of an entire unit. From a cost perspective, this multiplier effect is critical. Lower unit cost, higher total spending. Individually, logistics vehicles are less expensive than combat platforms. They often feature commercial-based designs, simplified protection, standardized components. This keeps unit costs relatively low. However, logistics vehicles are required in large numbers. And over time, volume drives spending. A fleet of hundreds or thousands of support vehicles can represent a major investment, even if no single vehicle is particularly expensive. Recovery vehicles, keeping assets alive. Recovery vehicles are among the most critical support platforms. Their role is to retrieve disabled vehicles, assist in repairs, prevent equipment loss. These vehicles are built for strength and reliability. They often include heavy-duty cranes, winching systems, reinforced frames. Cost characteristics. Recovery vehicles cost more than basic transport trucks, but far less than combat vehicles. Their value lies in preservation. Recovering a vehicle for repair is significantly cheaper than replacing it. In economic terms, recovery vehicles protect investment. Maintenance as cost control. Every recovery operation reduces long-term spending. A vehicle repaired and returned to service preserves training investment, avoids replacement cost, maintains fleet size. This makes recovery vehicles one of the most cost-effective assets in the fleet. Their cost is justified not by what they do, but by what they prevent. Engineering vehicles shaping the environment. Engineering vehicles support mobility and infrastructure. They are responsible for road construction and repair, obstacle removal, field fortification support, infrastructure maintenance. These vehicles are essential in maintaining operational flow. Without them, movement slows. Cost perspective. Engineering vehicles are often adapted from civilian heavy machinery. This allows lower production costs, easier maintenance, access to commercial supply chains. However, military adaptation increases cost through reinforcement, specialized attachments, enhanced durability. Still, compared to combat platforms, engineering vehicles remain cost-effective. Volume drives cost. Engineering tasks are constant. Roads degrade. Bridges require reinforcement. Infrastructure must be maintained. This means engineering vehicles are used frequently. Their high utilization rate increases wear and tear, maintenance needs, replacement cycles. Even with moderate unit costs, sustained use generates significant long-term expense. Fuel trucks, the quiet drivers of mobility. Fuel transport vehicles may be the least visible and most essential assets. Every vehicle depends on fuel. This makes fuel trucks indispensable. They support tanks, IFVs, artillery systems, support vehicles. Economic reality. Fuel trucks themselves are relatively inexpensive, but fuel logistics represent a continuous cost stream. This includes vehicle maintenance, fuel handling equipment, storage and transport infrastructure. Fuel is consumed constantly. Unlike equipment, it cannot be refurbished or reused. This makes fuel logistics one of the most persistent cost drivers. Transport trucks moving everything else. Transport trucks move ammunition, spare parts, equipment, personnel. They form the connective tissue of the logistics network. Their flexibility allows planners to adapt to changing requirements. Cost structure. Transport trucks benefit from commercial design influence, standardized parts, scalable production. This keeps unit costs low. However, like fuel trucks, they are needed in large numbers. Their cumulative cost becomes substantial over time. Standardization as a cost strategy. One way to manage logistics cost is standardization. Using similar platforms across roles allows simplified maintenance, reduced spare parts inventory, faster training. This approach reduces complexity. Many logistics fleets prioritize reliability over specialization. This reflects a cost-conscious design philosophy. Maintenance and lifecycle cost. Support vehicles experience high usage rates. This leads to frequent maintenance, regular part replacement, accelerated wear. However, their simpler design allows faster repairs, lower skill requirements, predictable costs. This predictability is valuable. It allows planners to budget accurately. Why logistics fleets grow larger over time? As operations scale, logistics requirements increase disproportionately. More vehicles require more fuel, more spare parts, more transport capacity. This creates a feedback loop. Growth in combat platforms drives growth in support vehicles. Over time, logistics fleets can outnumber combat vehicles several times over. This is why they represent the hidden majority. The cost of invisibility. Because logistics vehicles are rarely seen, their cost is often underestimated. They do not dominate visuals or headlines. Yet they consume significant funding, personnel resources, maintenance capacity. Their invisibility does not reduce their importance. It masks it. Resilience through redundancy. Logistics systems are built with redundancy. Multiple vehicles perform similar roles. This reduces risk. If one vehicle is unavailable, another can replace it. Redundancy increases fleet size and cost, but it ensures continuity. Why support vehicles are rarely replaced quickly? Unlike high-profile platforms, support vehicles are replaced gradually. They remain in service as long as they are functional. This extends service life, but increases cumulative maintenance cost. Once again, cost accumulates quietly. Logistics as the true measure of endurance. Modern conflicts are defined by endurance. Logistics vehicles enable that endurance. They do not deliver dramatic capability. They deliver continuity. From an economic perspective, they are among the most important investments. Understanding the hidden majority.
When we account for logistics and support vehicles, the scale of modern military spending becomes clearer.
They may not be expensive individually, but in aggregate, they represent a major share of total cost.
They are the silent enablers.
Transition to the final chapter.
With the full spectrum of vehicles in view, from frontline platforms to support fleets, we can now step back and examine the overall picture. In the final chapter, we bring all these elements together to understand total cost versus strategic value.
When numbers matter more than price.
After examining each category of vehicle, from armored transports to air defense systems and logistics fleets, a larger picture begins to emerge.
Modern warfare is not defined by a single platform.
It is shaped by how systems interact over time. And at the center of that interaction is a simple but often misunderstood relationship.
Cost does not equal effectiveness.
A high price tag does not guarantee strategic impact. A lower cost system does not imply reduced value.
What matters is how resources translate into sustained capability. Understanding strategic value. Strategic value is not the same as technical performance.
A system can be advanced, precise, and powerful,
yet offer limited strategic impact if it cannot be deployed consistently. Strategic value is determined by
availability,
sustainability, integration, endurance. In long conflicts, these factors often outweigh individual performance metrics.
A system that is present and functional over time contributes more than one that excels briefly. The misconception of most expensive wins. Public discussions often focus on the most advanced or expensive systems.
This creates the impression that superiority is determined by price.
In reality, cost is only one variable. Expensive systems often deliver
specialized capability, enhanced protection, advanced integration. But they also introduce constraints. Limited quantity, long replacement timelines, high support requirements.
These constraints shape how and where such systems can be used.
Quantity versus quality, a persistent debate. The debate between quantity and quality is not new.
What has changed is the scale of cost difference between systems.
Modern high-end platforms may cost several times more than older alternatives. This forces decision-makers to ask difficult questions. Is one advanced system worth multiple simpler ones? Does superior performance offset reduced availability? Can support infrastructure sustain the higher cost option? There is no universal answer. The correct balance depends on context.
When quantity becomes a strategic advantage,
quantity provides flexibility. A larger number of systems allows for continuous presence, rotation through maintenance, redundancy. This reduces risk. If one system becomes unavailable, another can replace it. In economic terms, quantity spreads investment across time. This is particularly important in prolonged operations. Quality as a force multiplier. Quality still matters. Advanced systems can perform tasks older systems cannot. Reduce exposure through protection. Integrate into broader networks.
These advantages can be decisive in specific roles.
However, they are often concentrated. Quality functions as a force multiplier, not a replacement for volume. The role of older systems. Older systems continue to play a critical role in modern conflicts. This is not due to lack of innovation, but due to practical considerations. Older platforms often offer proven reliability, lower operating costs, Established logistics. Faster replacement. They may lack advanced features, but they excel in consistency. In strategic terms, consistency builds endurance. Why replacement is not always optimal.
Replacing older systems with new ones seems logical.
But replacement introduces high acquisition cost, training demands, infrastructure changes.
Upgrading or refurbishing existing systems can preserve capability at a fraction of the cost.
This approach allows gradual modernization, controlled spending,
maintained readiness. It reflects a strategy focused on continuity rather than disruption.
Cost over time versus cost at purchase. One of the most common misunderstandings is focusing solely on purchase price. Lifecycle cost tells a different story. It includes maintenance, training, logistics, upgrades.
A lower-cost system with predictable lifecycle expenses may deliver more value than a higher-cost system with uncertain long-term demands.
This is especially true when budgets must support operations over many years.
Availability is a strategic metric. A system that is unavailable contributes nothing.
Availability depends on maintenance cycles, spare parts, training pipelines. Lower-cost systems often score well here.
They can be repaired quickly and returned to service. This increases effective fleet size,
even if individual performance is lower. The importance of replaceability. Replaceability is a form of resilience. Systems that can be replaced or repaired quickly reduce strategic risk. High-cost systems are often irreplaceable in the short term.
This encourages cautious use.
Lower-cost systems can be deployed more freely. This difference shapes operational behavior. Integration over individual excellence. Modern military effectiveness depends on integration. Systems must communicate, support one another, share information.
An older system integrated into a broader network can remain effective. Integration extends the value of existing platforms.
This reduces the need for constant replacement. Economic endurance as a strategic factor. Wars are not decided by single engagements. They are decided by endurance. Economic endurance depends on sustainable spending, industrial capacity, logistics efficiency.
Systems that align with these factors offer greater strategic value.
High-cost systems must be justified not just by capability,
but by their ability to fit within long-term planning.
Why lower-cost systems still matter?
A lower-cost system used consistently can sometimes matter more than a high-cost system used sparingly. This is not a criticism of advanced technology.
It is an acknowledgement of reality. Consistency creates presence. Presence shapes outcomes. Lower-cost systems enable wider deployment, longer operational periods, greater redundancy. These factors often outweigh peak performance. The role of mixed fleets. Most modern forces operate mixed fleets. This combination allows advanced systems for specialized roles, lower-cost systems for routine tasks. Mixed fleets balance cost and capability. They reduce risk by avoiding dependence on a single platform type. This approach reflects lessons learned over decades. Strategic value is contextual. There is no universally best system. Strategic value depends on mission requirements, duration, available resources. A system that excels in one context may be unsuitable in another. This is why diversity of platforms persists. Measuring success beyond hardware. Success is not measured solely by hardware. It is measured by sustainability, adaptability, integration. Systems that support these goals offer the greatest return on investment. Seeing the whole picture. When viewed individually, each system tells a partial story. When viewed together, a pattern emerges. Modern warfare is shaped by cost management, logistics, endurance. Understanding this helps explain why decisions sometimes prioritize affordability over innovation. Why this chapter matters. This chapter reframes how we interpret military capability. It challenges the idea that cost equals strength. Instead, it highlights how strategic value emerges from balance. Balance between quantity and quality, old and new, cost and capability. Transition to the conclusion. With this perspective, we can now step back and consider what all these systems reveal about modern warfare. In the final moments, we move from analysis to understanding. Not of vehicles, but of strategy itself. This video wasn't about who was right or wrong. And it wasn't about tactics or battlefield decisions. It was about understanding scale. Every vehicle represents industrial capacity, economic commitment, and long-term strategic planning. When we understand cost, we understand why modern conflicts look the way they do. If you found this breakdown useful, consider liking the video and subscribing for more neutral, documentary-style analysis of modern military systems.